Aluminum today. We used to use aluminum cans. We're going to just use plain aluminum foil today. So there's going to be two reactions that take place today, and then we have to let it set and let Mother Nature do the rest. So the first reaction is going to be, you're going to take some aluminum, react it with potassium hydroxide and water, and you're going to produce potassium aluminum hydroxide and hydrogen gas. Now we will do this in the hood, so the hydrogen gas is being pumped out of the building. Hydrogen gas can be explosive in large amounts. Then, once we produce this potassium aluminum hydroxide, we're going to add sulfuric acid and produce potassium aluminum sulfate, and then we will leave that set for a week, and the water will evaporate. As the water evaporates, the solution will become saturated. Once it becomes saturated, the crystals will precipitate out. Sometimes you get large crystals, sometimes you get small crystals, but you'll get this potassium aluminum sulfate decahydrate. Now those are 12 water molecules bonded to the crystalline structure of the substance. So we will do these two today, and then we'll come back after this has been created by Mother Nature and do this reaction. So we'll do the first two reactions today. Okay, I weighed out my aluminum foil, and if you notice, I put it in the beaker, and that weighs approximately 1.5 grams. And then I measured out my 8 molar potassium hydroxide. Now I'm going to add that to that, and the reactions should start. And if you remember, there's a gas being produced. Do you remember what gas will be produced? Okay, now the reaction is taking off. You can see the vapors coming out because it generates a lot of heat. So it's very exothermic. Again, if we'd use a can, the reaction would probably take a good 30 to 45 minutes because of the paint and plastic on the surfaces. So in our beaker, we should have potassium aluminum hydroxide. Now we're going to add sulfuric acid to that, and first some water. So I'm going to add 75 milliliters of water. Then I'm going to add my indicator, which is methyl red. I want to make sure it's basic, and the color may be hard to see because of the darkness. It's very difficult to see the color change. I'll put a little more indicator in because I'd rather have too much than not enough. Okay. But it should have had a yellowish color to it, but because of the dark particles floating around in there, it's not visible. Okay? So now I'm going to add, okay, now I measured out my sulfuric acid, 10 molar, and I will add this to the solution with stirring, and it's approximately 15 mils. If you notice, it's sort of forming a thick gelatinous product. Sort of looks like Pepto-Bismol if you're familiar with it. Okay. So now that's my potassium aluminum sulfate. But I want to get it back into solution, so I'm going to have to put it on a hot plate and heat it to dissolve it. Notice I'm stirring it while heating it because I want it to dissolve. And you notice there's some on the sides I will have to rinse in. If you notice there's some deposits on the edges of the glass, I will rinse those in once the liquid gets a little hotter. If you notice, it appears that most of it is dissolved. There's just a wee bit left. So I'll let it warm for another 30 seconds or so. Once this is done, I will take it off the heat, leave it uncovered, and give Mother Nature time to evaporate it. As she evaporates the water, the concentration of the solvent will go up and eventually it will precipitate out. So we should get crystals. Again, there's no way to predict what type of crystals you're going to get. You may get small ones, you may get big ones, you may get multiple ones. It all depends on the conditions and that time and what temperature. If we were making crystals for use, then everything would be a controlled experiment where the temperature, the humidity, etc., everything would be monitored and checked so you got the exact same crystals every time. Okay, now if you notice it's clear, notice I'm going to rinse my rod because if there's sample on the rod, I don't want to lose sample, so I'll just rinse it into the beaker. So whatever was on there when I was stirring goes into the beaker. And basically that is done now, and we will let that set and cool and evaporate. Uncover it again.